In this tutorial, we will be adding some test tools. First, we want to make sure that all our tests are independent of each other. Currently, this is not the case. Running our tests step by step exposes some interesting behavior. We are creating some game objects in the test phase target. Currently, this is totally fine, but after the test has finished, those game objects should disappear. But this is not the case. This means they will be present during other tests, which could corrupt the other tests, lead to odd behavior, or make them completely invalid. To fix this, we first add our test tools as a normal C# script. This script right now only needs the Unity engine and the NUnit test framework. Sorry, short interruption. Because of several small oversights, I have refactored the test tools. For instance, we don't need to implement mono behavior here. So in the repository there is a refactored version of this tutorial available. But now back to the video. We add a new abstract class and call it base test class. It will contain one method with the teardown tag. Methods with this tag will run after each test, and so we can use this to destroy our game objects within the scene. We will use Unity's findObjectsOfType method to iterate over all objects in the scene. We also supply it with a true value so that we also find all inactive game objects. And then we call object_destroy on the object. Our tests can now implement this base test class. And now we can see when we run our camera controller tests again step by step that the game objects are destroyed after the test has finished. In the future, all tests we write should always implement our base test class to make sure the scene is always cleaned up between tests. In our last tutorial, we discovered an issue with vectors that should be equal, but due to rounding errors cannot be asserted as equal. We will address this by writing our own method to assert equality between vectors. This method requires testing again, so we add tests for our test tools. Let's use the first test to illustrate the issue. We will create two vectors and assert their equality by two different methods. First, we compare equality with the double equals operator, as Unity suggests, and then we'll compare via the assert equal method. I also added some strings which will be displayed in case the assertion fails. As the test currently stands, those two vectors are not equal and are displayed as such. Now we made them equal and our test tells us so. But when we make the difference between the vectors as small as possible, both conditions in our test are satisfied. Our equality assertion should not be thrown off by such a small difference. The first unit test will assert a difference between two vectors. This means we expect an assertion exception to be thrown when we compare unequal vectors. As always, we add the method without any implementation. With the minimal approach, we simply throw the expected exception. Next, we compare two equal vectors. To satisfy both tests now, we simply call the normal assert are equal function. Next, we will be comparing two almost equal vectors, which our method should recognize as equal. To implement this behavior, we now compare both of the vectors with the double equal operator. In case of inequality, we want to see the actual vectors that have been compared. This means we write a test in which we catch the assertion exception and check its message. The message should show the expected and actual vector. Unity normally displays vectors with a one-digit precision, but we want to be more precise. Via string format, we construct our string with the precision that we want. I believe a 10-digit precision should be sufficient in most cases. Now we simply need to build a string for the exception message. I temporarily added the assertion a second time to see how it looks in the test runner. And now whenever this assertion fails, we can see in the test runner the vectors with a 10-digit precision for each coordinate. But let's remove the doubled assertion because it's not actually part of the test. In the repository you can find another overload of this function which accepts a delta as the maximum difference allowed in each dimension. But that's it for this tutorial. Next time we will create a generic input controller and connect it with our movement. Let me know what you think, and thanks for watching.